Okay, so hello everyone. Can you hear me?
Yes, I can hear you.
Okay, so just we are waiting some 1 or 2 minutes for joining all of the other participants, then we will start.
While waiting, can I ask something?
Yeah, no
I
problem.
was not I was not in yesterday. I didn't manage to get on time.
Okay, so did you get the recorded video class?
Did I get? Yes, I got the recording.
Yeah.
Now I have an issue with my I saw that you send the codes via WhatsApp. I'm asking if you can send them through email.
Okay, no problem. So after completing the today's session, we you can also get the
Yes.
1 hour for the live training for the problem solving class. Okay. Then after completing the 2 hours live training, we also try to discuss about the problem solving on any problem you face. We also try to discuss about that. Okay. So after completing the 2 hours live training session.
Okay. All right. I mean the codes that you sent via WhatsApp.
Yeah.
Can't you send them through email? I have a problem with my WhatsApp. Can't you send them through email?
Okay, so basically, okay, so I will send you all of those things. Your again, okay. So basically, all of the code I already saved, and also make the PDF file about all of this code. Okay, so I also send you all of this code. Then you can easily access from this PDF file. You can easily access all of this code. There is no problem.
All right. Thank you very
Yeah.
much.
Okay, so we also try to discuss about the problem, all of this problem. We also try to discuss about after completing the 2 hours live training session. Then talk about this problem solving part. Okay, so you can note down about that. So after completing this today's session, we also try to discuss about the problem, all of this problem which we face regarding the first class. Okay, so now we'll start. Okay, so I simply share my screen. Okay, so now can you see my screen? Is it visible?
Yeah, for me it's visible.
Okay, okay, so let's go. Okay, so let's go. So, hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So, basically, today is our second number of class, and previous day we also try to complete the first day. Okay, so basically, today's I also try to discuss about all of this topic, how we can easily filtering and displaying the satellite images, Landsat and Sentinel, how can easily filtering and also displaying the satellite images. We also try to discuss about that how you can easily use the different types of band combination such as true color composite, false color composite, or other types of band combination, how you can easily use. We also try to discuss about that. Then how you can easily export the satellite images from the Google Earth Engine platform. So Google Earth Engine platform, we can also export the satellite images and use this satellite image for the different types of geospatial software. And how to import, filter, reduce, clip, and display any data set in Google Earth Engine platform. We also try to discuss about that. How you can easily import, filter, reduce, clip, and display the data in Google Earth Engine platform. And how to make the time series chart of NDVI. mainly Modi's dataset we also use for creating the NDVI chart, and also try to show you that also Landsat image, Sentinel image, how you can easily create the NDVI or any types of indices and also make the time series chart. I also try to cover all of those things. Then how you can easily export any shapefile from the Google Earth Engine platform, and how to calculating any indices from the satellite images, and also make the time series chart. Okay, so let's go about that. So first of all, Earth Engine public data catalog. Okay, so Google Earth Engine is a totally cloud-based platform. Okay, so it is a cloud-based platform, so that's why when you are using this platform, you don't need to download any types of satellite imagery. Okay, you don't need to download any types of remote sensing data. Okay, so anyone any question? Any question?
Good afternoon, sir.
Yeah, good afternoon.
Yeah, you know I am Francophone. I am from Burkina Faso, and when you go very fast, I can't understand all these things you are saying. Just to make this comment. Thank you.
Okay, so if you don't any understand about that, you can also make the question or also make the comment. And I also write the when I write the code, and I also try to write the comment. Okay, so that when you want to read the code, you can easily understand what can I do. Okay, so there is no problem. Okay, so I also write mention the some comment about that, so that when you can read the code, you can easily identify where I use the code. You can easily understand. Okay, so let's go. So Earth Engine public data catalog. In this Earth Engine public data catalog, we can easily access all of those remotely sensed data, such as Landsat, Sentinel, MODIS, different types of train data set, different type of dam data, okay, different types of land cover data, atmospheric data. We can easily access from the Earth Engine public data catalog. And this data set is updating daily, okay, and in this Earth Engine public data catalog, we can easily access more than 200 public data set, more than 4,000 new images every single day, more than 5 million images, and also more than 5 petabytes of data. Okay, and this is the link about this Earth Engine public data catalog. Okay, you can simply go to this link, then you can easily access the Earth Engine public data catalog. Okay, or if you want, simply open your code editor. Suppose I open my code editor, go to this link and open my code editor. From this code editor, I also access the Earth Engine public data catalog. Okay, so I simply open my code editor. And you can see, simply click on the search bar and go to the browse data catalog. Okay, so now it open the Earth Engine public data catalog page. Okay, so in this Earth Engine public data catalog, where you can find all of the climate and weather data, surface temperature data, climate data, atmospheric data, weather imagery, Landsat, Sentinel, MODIS, high resolution imagery, geophysical dataset, train dataset, different types of dam dataset, land cover dataset, cropland dataset, other geophysical dataset. Okay, so in this time, we work all of those remotely sensed data and without downloading. Okay, so basically this is the big benefit for using the Google Earth Engine platform. When you are using the ArcMap software or QGIS software, you have to download the satellite images, and one satellite image is the very huge file, more than 1 gigabyte or 2 gigabyte. In this time, we get the opportunity without downloading the satellite images, we can easily use it. Suppose you need to the Landsat image, click on the Landsat image. You can get all of those Landsat image collection. Landsat 9, Landsat 8, Landsat 7. All of those image collection you can easily get for the Landsat. You can see Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. All of those image collection you can easily access from here. Suppose you need the Sentinel imagery. Click on the Sentinel. We can easily access all of the Sentinel imagery. Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5. All of the Sentinel image collection we can easily access from here. You need the MODIS. Simply click on the MODIS. You can get all of those MODIS satellite imagery and also get all of those MODIS product. So you can see a lot of MODIS product. MODIS Albedo daily 500 meter, MODIS BRD Albedo quality, surface reflectance data, snow cover data for the MODIS, land surface temperature for the MODIS, okay, surface reflectance daily global, okay, also you can see terra thermal anomalies, MODIS, BRDF, albedo. We can also get the some derivative data set, okay. So basically this data set derived from the MODIS, okay, and this data set also called the ready-made data set, okay. Derivative data set also called the ready-made data set. This data set already ready, okay. Suppose you can see the MODIS leaf area index, okay. Basically when you want to do for this analysis using the raw satellite image, you have to apply lot of algorithm, but in this time it automatically created this dataset, automatically provide you leaf area index. When you are using this dataset, you can get the leaf area index. Suppose also you can see the terra surface reflectance dataset, terra surface reflectance 8D global dataset. Also you can see land surface temperature dataset or LST dataset. Okay, basically this dataset is the derivative dataset, and this dataset derivative from MODIS. So that's why it's also called the MODIS product. So this type of MODIS product we can easily access from the MODIS. You can see land surface temperature dataset. Also you can see terra thermal anomalies dataset. Also you can see terra gross primary productivity dataset. Also you can see terra net evapotranspiration dataset, terra vegetation indices dataset. Okay, terra vegetation index 16 global dataset. So all of those dataset we can get as the derivative product of MODIS. All of those dataset create from the MODIS, and we can easily use this type of data and also make the analysis for our region. Okay, so in this time I try to discuss about this slide, how we can easily import the data in Google Earth Engine platform. Okay, so we can get the Earth Engine public data catalog, and we can get all of those data. So now how I can import the data in Google Earth Engine code editor. Okay, then how to filter this data. So different way for filtering this data, we'll also try to discuss later. Then how to reduce this image collection, and how to clip on your own shapefile. Suppose you want to need the NDVI map for the Dhaka city, you want to need the NDVI map for the Bangladesh. So just we need to clip with your shapefile, then you can get the result. Then how to display the result on the map, and how to reprojected the scaled pixel value. Okay, so it's very important for reprojected scale pixel value. Sometimes we did not get the proper scale value. Suppose NDVI result is the -1 to +1, but sometimes you did not get the result within this range. Then we also need to reprojected the scale pixel value. So all of those things we try to complete it step by step. So let's go. So first of all, suppose in this time I want to work with a data set. Suppose I want to work with suppose this data set. I want to work with this data set. Mainly it's a terra vegetation indices. Okay, so I want to use the 250 meter resolution. You can see basically this is the resolution 250 meter. Also you can see 500 meter. Okay, I want to use the 250 meter resolution for terra vegetation indices. Okay, so basically this data set provide you about that surface, what is the condition of the vegetation on the surface. Okay, and what is the algorithm they're using for creating the data set from the MODIS. You can get all of the information in the description, you can see. So basically this they are using at the MODIS product. It's a MODIS product. It mainly provides the vegetation index value per pixel basis. Okay, and mainly it provides the two primary vegetation layers, EVI and NDVI. Okay, and what is the algorithm they are using in here. We can get all of those things in here, and what is the data they are using in here. Basically it's a derivative data set from the MODIS. Okay, and you can see the MODIS EVI and NDVI product are computed from the atmospherically corrected. So basically this data set already atmospherically corrected. Okay, so that's why we don't need to use the again for the atmospheric correction. It already done. Okay, and all of those unnecessary pixel values such as water, cloud, heavy aerosol, cloud shadow already removed from this data set. So that's why when you are using this data set, we can get the very clear NDVI map for any region. Okay, so let's go how we can easily work with this data set. So this is my data set, and this data set availability date. We can get the data set from year of 2018 February, from 2023 2nd February. This is a time period, and it also updating. Okay, so we can get the dataset provider. This is a dataset provider. Okay, And also you can see the art engine snippet. So basically this is the unique ID of this data set. Every single data set has a unique ID. And this unique ID for that data set. Okay. So in this time, I want to work with this data set. Okay. And also you can see this data set band. Basically, you can get the two type of band. And this data set resolution is that 250 meter resolution. Okay. And we can get the data set is the NDVI band and EVI band. Okay. So in this time, I want to work with this data set. So first of all, I need to import the data set in my code editor. How I can import that? There is a two way for importing. If you want, simply copy this art engine snippet or unique ID. Simply copy that and paste on the key code editor. Okay, and give a variable name. You can use any variable name. Before the variable name must be used at the var keyword and put the variable name, suppose modis, and store it here. In this time, this dataset is imported. So this is a one way for importing the dataset. And what is the another way? You can simply search here. Suppose modis NDVI. You can get, I use the dataset. Image is 60-day global, 250 meter resolution. I want to use this dataset. Click on here. Here I can get all of this information about this data. Same information I want to get in here. So just I simply import that. So this dataset is also imported. So there is a two way you can use and import your dataset. Any dataset, not only for that. All of those dataset in the Art Engine public data catalog, Landsat, Sentinel, Modis, any dataset when you want to import that, you can just follow the two way. If you want, you can simply search the dataset and import, or if you want, simply copy this Art Engine snippet and paste on the code editor and give a variable name. Okay. So anyone any question, you can ask me. Okay, so basically NDVI is that normalized difference vegetation index, and EVI is the enhanced vegetation index. So NDVI is mainly working for the greenness, okay, and EVI is working for the quantify of greenness. I think some networking issue. Okay, so can you hear me?
Yes, yes.
Okay. Okay. Okay, some networking issue. Okay. So basically, NDVI is that NDVI and EVI. It's almost same, but when you want to quantify the vegetation greenness, then we are using here the NDVI. Okay. And what is the EVI? EVI mainly working for the current of some atmospheric condition, and canopy background noise is more sensitive in areas with the dense vegetation. So EVI is helpful when you want to identify the vegetation in the dense area. Okay. Suppose NDVI and EVI, you can simply search on the Google, then it's a better idea. Okay, I also show you that. Suppose NDVI and EVI difference. Okay. So you can also read this article, then also better idea about that. So one is that only for the NDVI is the only for the quantify. You can see Landsat. Okay, EVI is similar to the normalized difference. We can use the quantify vegetation greenness. Quantify vegetation greenness used for the NDVI, and EVI is mainly correct for some atmospheric condition and canopy background noise, and is more sensitive in areas with dense vegetation. Then we are also applying the EVI. Okay, and also give the practical example about that, two things about the NDVI and EVI. Okay, and how it will be work, we can get that. And we also try to solve that equation, how you can easily calculate this type of equation. So further, we also try to discuss about that when I talk about the Landsat and Sentinel imagery. Okay, but in this time, Modis, this is the derivative product, this product automatically provide NDVI and EVI. Okay, so that's why in this time we are not applying this type of equation. But when we are using the Landsat image or Sentinel image, then we are using here this type of equation, and then find out the EVI and also NDVI. So quantify of vegetation and dense vegetation of EVI, we try to find out using the satellite images. Okay, so I also send you the link in the So you also try to read that, then also get the better idea. For the EVI and DVI. Okay, so now we can get this result. You can see. Okay, you can say I can import that two way. If you want, you can simply import from here, or simply copy the snippet and paste here. Okay. So in this time, suppose I want to use the first one, so simply remove that. So my dataset is the imported. Okay, now my dataset is the imported. Okay. In this time, this dataset or this image collection has a two product, NDVI and EVI, or two band, NDVI and EVI. But I want to work with for the NDVI. So that's why I need to select the NDVI. Okay. So that's why I simply use a function, use here the select function and put here the NDVI. Okay. So now this is the full image collection. It contains NDVI and EVI. I want to select only for the NDVI. Okay. So you can see here, I just simply, first of all, image collection. This image collection contains two band, NDVI and EVI. I want to work for NDVI, so I select the NDVI. Okay. So now you can see this dataset availability is that year of 2000 from 2023. Okay. But I want to need the data for year of 2020. Okay. So that's why I need to filter date. I want to select a specific time period. So I simply use a function filter date and put your own time period. Suppose you want to need the result for the 2020 summer season, 2020 rainy season or wet season, or any time period you can put. There is no problem. So I put the time period, suppose year of 2022, 1st January, and in that will be that I put at the time period 2022 December 31. So this is my time period. You can choose your time period based on your research work. Okay. So I simply put this time period. And now let's check how many images is available. I want to check it, how many images is available. So simply use the print function and call the modis and use the function size function. Basically, in this time, how many images is stored in here, it determines the size function. Okay, so let's go. We can check how many images. And it showing the result for the whole world. Okay, so we can get the result 23. Okay, we can get the 23 result, 23 images for the 1 year. Okay, so if you want, you can simply, we can get the result 23. Okay, and I can simply suppose 23 multiply with the 16. We can get almost 368, almost 1 year. 1 year equal to 365 days. Okay, almost it will be covered the 1 year. So 23 images is covered this 1 year. Okay, because this data set you can see, this data set is then 16-day global. It also showing the 16-day global. Okay, so that's why we can get the data set 16-day time period. Suppose I can get the first data 1st January, then second image I can got in the 17th January, then 2nd February. If you want to check the time period, suppose I simply print the information about that modis or this variable, you can get all of the information you can check. Here I can get 23 images. I paste in, I click on here, I can get the result, you can see. First image, year of 2020, 1st January, then 17th January, then 2nd February, 18th February, 16 March. So time interval is that 16 day. Okay, so that's why you can get the data. This data is also called 16-day global. Okay, so 23 into 16, we can get almost 1 year or 365 days almost. Okay, so I can get my image collection. So this is my image collection. Okay, I get my image collection. So total 23 images for the 1 year. Okay, so now I want to show the map in here. Suppose I want to show the whole world NDVI map first. So for whole world, I want to check what is the NDVI map between the year of 2020, what is the condition of the NDVI for the whole world. So in this time, I need to reduce this image collection. So why I reduce this image collection? It's very important because you can see here I can get the total 23 images, and this 23 images is not captured or is not derived at the same time of the year. It's showing the different time period. First image 1st January, 17th January. Also you can see the image for that 2nd February, 18th February, 6th March. Okay, different date we can get this different images. So in this time I need to reduce this image collection for make the combination. In this time I want to use the reduce technique for calculating the average pixel value. Calculating the average pixel value means that I want to calculate total 23 images, calculated the average pixel value of NDVI. Okay, so in this time I want to use the reduce function. In Google Earth Engine platform, reduce is an statistical function. So I simply search the reduce. Suppose ee.reducer. And find out the reduce function. You can see reduce. So reduce is an statistical function mainly when you want to calculate the different types of statistical part, such as calculated the mean, median, mode, standard deviation, this type of analysis. Then we need to use at the reduce or reducer. Okay, in this time I want to use at the reducer. So take a variable. Using the reduce, I want to calculate the average pixel value of NDVI. So take a variable, suppose average NDVI, and I call this modis because it is stored total 23 images. I want to use this total 23 images and apply the reduce function so that I can get the average result of the NDVI. ee dot reducer dot min. In this time, use this function mainly calculated the average result and stored it in here. So now let's check about this average pixel value of NDVI from total 23 images. We can check it. Suppose use add the map.add layer and show the result. So simply copy this variable name and paste here. Okay, so now you can see it will display the result. Only we can write the 3 line of code and now it display the whole world NDVI map. Okay, but this map is not colorful because I did not add the visualization parameter. After the object name, we always put here the visualization parameter. So in this time I simply copy their default visualization color. You can see they already provide some color code. Just I simply copy their color code from here. And in this time you can see this result is not reprojected because it's showing the mean NDVI value 0 and max 8000. But we already know about that NDVI index. This index value range will be -1 to +1. Okay, so that's why we also need to reproject this value further for the more analysis. I simply copy that and then paste here after the object name. So now I can get this colorful map, and from this map we can easily identify for that whole world NDVI map year of 2020, and we can easily identify where is the dense vegetation, where is the no vegetation. You can see this is the ice region. Also you can see desert region, very less vegetation. Okay, we can easily get the whole world NDVI map. Okay, year of 2022. I can get this map for the whole world. Okay, but in this time I don't need for the whole world. I need only for the specific region. So a specific, suppose Bangladesh or Dhaka city or other types of country, a specific region, how I can get that. So for that we already covered this part. Suppose you need to import your shapefile. In previous class I also try to show you that how you can easily import your boundary shapefile, and also you can get the data about that US data set. Mainly it provides the international country boundary polygon. I simply use this because I want to make the NDVI map for the country boundary of Bangladesh. So Bangladesh country boundary I can get from here, from this data set. So now I have to filter the data set. So let's go. Take a variable, suppose RY. And previous class we also try to discuss about that how we can easily filter. So I write the code. Same code I write. Suppose country name such as Bangladesh. Okay, so now I import my boundary shapefile. Bangladesh boundary shapefile is stored in this variable. In this time, what can I do? I just simply click. In this time, you can see average NDVI. Okay, average NDVI. When I want to add map.add there and call the average NDVI, it show the result for the whole world. But I don't need for the whole world. I need only for the Bangladesh. And Bangladesh boundary is stored in here. In this time, I simply use here the clip function. Just use here the clip with RY. RY is the my boundary shape file. Click to the run. In this time, I can get the result only for the Bangladesh. Okay. And I also need to focus the center of the Bangladesh map. So use here the map dot center object and call the RY. Suppose zoom level is the suppose 8. Click to the run. In this time, it automatically center view of the Bangladesh boundary, and we can get the Bangladesh NDVI map in here. Region. Okay. Not only for Bangladesh, we can easily access all of those country boundaries. Suppose I can simply put the name such as Saudi Arabia. Click to the run. So now it displays the result about the Saudi Arabia NDVI map year of 2022. Okay, here I can get this map of the NDVI, and we can get the very little NDVI place. You can see very less vegetation. We can get that some the cropland in this region. Okay, and this map is represented the year of 2022. Suppose I need this result for the another region, so put here this another country name. Suppose Kenya. Click to the run. So now I can get this NDVI map of the Kenya. Suppose I put this country name such as Botswana and click to the run. Now I can get this result about this NDVI map. So any region in the world, we can easily create it, this NDVI map, and this map is the year of 2022 of this NDVI map. Okay. And finally, we can also export this map. Okay, we can easily export this map and also work with the ArcMap software for creating this type of or research paper map or your presentation work map. Okay, so how you can easily create that, I also try to show you the further class. Okay, I can get the result of the NDVI map, but this map is not correct. Why it's not correct? Because if you want to check the, click on the Explorer tab and click on this map, you can see I can get the result is the 5,389. I click on here, I can get the result 855. It means that in this time it's not reprojected. Okay, this result is not reprojected, so that's why I can get the result look like that. If you want to check on Google, suppose I put this Google, suppose NDVI value range, I simply search there, it directly showing the result. NDVI value range will be +1 to -1 all time. So all of those index, NDVI, NWI, EVI, SAVI index, MLEWI index, any types of index, we can get the result within this range, -1 to +1. But NDVI result, we can get this range. But in this time, you can see, I can get the pixel value look like that, 300, 3027. This type of result I want to get in here. It means that it has some problem. And this problem is that reprojected of a scale value. Okay, so how I can reprojected this scale value? I create this map, but this pixel value is not correct. Okay, so in this time I need to reprojected this scale value and find out this correct NDVI map. Okay, then we can get this result within -1 to +1. So let's go how we can easily do that. And this is our NDVI map we created. Now we talk about the reproject, the result. How can we get the reprojected scale value result? If you want to check the result, your information sheet about the data set, they are already provided a scale value. You can see this is the scale value of this data set. Okay, so in this time, when I multiply all of those images with this scale factor, then it will be reprojected. So that's why they are provide the scale. So with data set, it's not only for the NDVI. With data set, you find out the scale value, you must be reprojected this scale for getting the correct result. Okay, some data set you did not get any scale because it's already reprojected, but this data, it's not reprojected, so that's why they are also provide the scale value. In this time, I just multiply this scale value with my images. Total 23 images I can got in here. So these 23 images I need to multiply. If you want to check how many images I want to get, I also check the again result. You can see print. I simply print this modis and use here the size function. Now I want to get how many images I want to got. Here I can go total 23 images. Okay. So now I just multiply with my scale factor 0.001, total 23 images I need to multiply. Okay. If you want to check all of those images, we already checked. You can see I print modis, click to the run. So it will be very easy. But when these 23 images capture at the same time, but in this time it's very difficult because you can see this image is not capture or this image is not derivative at the same time. It will be derivative for the different time period. 1st January, 17th January, 2nd February. So it's very difficult when you want to multiply at the same time. In this time, we need to apply a technique. This technique is that when you want to multiply this all of those images, suppose I can get total 23 images. In this time, these 23 images, I need to multiply with my scale factor. My scale factor is the 0.001. At the same time, all of those images, I need to multiply. So what can I do? In this time, I use the function concept. In previous class, I also try to discuss about the function. Function mainly reuse your code and make it easier to read. In this time, I want to generate a code or generate a function. This function automatically calculated with my scale factor all of those images at the same time. So let's go about this function, how we can easily create the function. Okay. So first of all, we need to write the function structure. So take a variable, put the any variable name as a function variable name. Any name you can use. I put the variable name, suppose scaled NDVI. You can use any name. Then use a keyword, function keyword. Okay. I put the keyword as a function keyword. And then put here the element name. Suppose in this time I put the element is the image. Okay. If you want, you can check the result. Suppose I can get the one image 0. Suppose I put the image 0. Then put here the image, suppose image 1. Suppose image 2. Image 3. Up to, suppose dot up to image 23. When you want to write this way, single by single image, you need to do a lot of time invest for write your code. For that, we are also applying another method. This method is that I take only for the one image. I do all of those things using this one image. Okay. So let's go about that. Then how we can easily implement all of the other images, we also try to discuss. I make here the curly bracket. In this curly bracket, I put my argument. My argument is that which one image I include in here, this image is multiplied with my scale factor 0.001. Okay. So what can I do? I just simply use the return function. Return this image multiply with my scale 0.001. Okay. 0.001. Okay. 0.001. Okay. So this is the multiply, but in this time you can check I get only for the one image, but rest of the 22 images what happened? Okay, so I take only for the one element and multiply with one image, but other rest of the 22 images is also available. I also need to multiply also those images. So for that, what can I do? I use a function, this function called the copy properties. In this time, you can see after multiply with this scale factor, this image or this element has a new properties. Okay, so I simply call these properties and copy these properties from system time start up to system time end. In this time, system time start means that our start date, and system time in means that our end date. Okay, between this time, all of those images, I apply the same properties after multiply with this scale factor. So that's why I use here the copy properties. And which properties I want to copy? I want to copy this image properties. So I call this image. And then what's the duration? I want to copy these properties, all of those images, which are available for the system time start and system time end. And system time start and system time end almost available 23 images. So in this time, when I use the copy properties, at the same time, all of those images is the multiply. Okay, so it's very good concept. If you have any question or any doubt about that, you can ask me. Okay, because a lot of time we are also using this function, this type of function for the also further analysis for the LST monitoring or other types of monitoring. We also need to use it. So it's very easy. Just you can say I again explain. I take a variable name scale and dvi, then use the equal sign. Okay, then put the function keyword and put the element. I take only for the one image. Only for the one image I multiply with my scale factor. Okay, but I have also rest of other images. Rest of 22 images is also available. I also need to multiply. So that's why I use the copy properties. After multiply with this value, this element has a new properties. These properties I want to copy. So that I use the copy properties and apply this from system time start and system time end. And system start means that start date and end is that end date. So between this time period, all of those images, apply this or get this or copy this same properties. So that's why it also multiply. Okay, and this is our function. At the same time, we multiply total 23 images. In this time, it has another question. You can see here, this code, only this code and this code, there is no connection. Okay, so modis, it stored 23 images and it's only multiply with image. In this term, I need to make the connection. So this code and this code, I need to make a connection. So this connection help you using the map function. You can see the map function about that. So map function, map, you can see map. Yeah, maps an algorithm over a collection. In this term, you can see this is my collection, 23 images. It's my collection. Okay, this collection I want to add with my function which I created. So that's why I need to use the map function. Okay, so map, you can say argument is the algorithm. Okay, so my algorithm is that, what is my algorithm? Algorithm means that it's my algorithm. Okay, this algorithm I connect with my collection modis. You can see, and we can get the result. Algorithm is totally depend on your own what's the algorithm you can write. In this time I want to write the algorithm for multiply all of those images at the same time. So now I connect these two things. Okay, so how I can do that? It's very easy. Just I can simply take a variable. Suppose I put the variable name is that, or if you want you can simply call the modis, simply call this modis. This is my collection. This collection I want to simply add with that. So simply use a paste here and use a function, map function, and then use the parenthesis and also close this parenthesis. So now it's connecting. Okay, so this function, this is my collection, total 23 images. this collection I want to add with my function which I created, or my algorithm which I created. So I connect that using the map function. So I simply call this collection and use the map function and connecting with that. So now it will be reprojected. So just I simply copy the scale and DVI. And now if you want to check how many images available after applying the scale factor, just simply copy that. And paste and use at the suppose size function and click the run. Now I can get how many images are available after applying the scale factor. I can get the same number of images. There is no change. Okay. In this time I can get the 23 images also, and this 23 image is the reprojected my scale factor. But first time I can get the 23 image, but it's not reprojected the pixel value. Okay. So in this time I want to do all of this work using this image collection, then I can get the result easily. Okay, so now in this time, anyone any question about this code for the reprojected or reprojected the scalable, you can ask me. Anyone any question or any doubt? Okay, so I have to write the comment. Okay. Anyone any question or any doubt? Okay, I'll write the comments such as I put here the import the boundary shape file. Okay, and I want to use here this data set, so I filter, I get the boundary shape file, and then I simply in here import the image collection of modis. Okay, and then select the NDVI band, then filter a specific time. Okay, and then I want this code, I want to check how many images are available. Okay, and this code I write for reprojected scale value. Okay, and this code for check the result, how many images are available, and then this code for calculating the average pixel value of NDVI, and also clip with your specific boundary. Okay, and this code for the NDVI visualization. Okay, and visualize the code different color, and this code for add a display layer of NDVI. Okay, so we also write the code, notation about all of this code. So that's why next time when you want to read the code, you can easily get that. Okay. So
I have a question.
yeah, please.
Can I see the screen?
Yes.
I don't see the screen.
Yeah. So now can you see my screen?
Like what?
Yeah.
Yes, I can see the screen now. If I go to like the visualization part.
Yeah, visualization parameter. We also need to change it after some time. You can see in this time it's showing the result. Mean it will be start from the 0, but in this time it will be -1 to +1.
Okay.
This is the range of our NDVI. Okay, so you have to change it.
So we are seeing the average NDVI
Yeah.
this time.
Yeah.
I'm asking if you can see the scaled NDVI.
Yeah. Okay, so it's also possible. We are also using here the Lancet image array for that. Forget the single time period image. Okay, so in this time, this image is the make the combination of total 1 year. Total 1 year image combination and create this NDVI map. So that's why you need to use at the average result. But when you want to use only for the single image, Suppose you want to use the image for the year of 2022, 10. Okay, then you can easily use the single image and use the single image. You can easily create this NDVI map. Okay, but in this time it create the composite of 1 year. 1 year we can get total 23 images. Okay, so that's why you need to create the mean or average pixel value of NDVI. Okay, so now let's check the result. So I simply call this scale NDVI. I simply copy this variable name and paste here, and then click the run. Yeah, please.
Scale NDVI process.
Scale NDVI process. Okay, so basically there is no any other algorithm is that in this time they are in Google Earth Engine platform. We can get the result for that globally they are provide. So globally this negative 2000 and up to 10,000 is okay for the global. But when I want to need the result for the regional, such as country boundary or any other shape file, then I need to reprojected the scale value. Okay, so that's why they also provide this scale value, look like that. So all of this image collection which I got, this image collection I need to multiply with this scale factor, then it will be reprojected. Okay, so that's why we need to multiply, otherwise we did not get the correct pixel value. Okay, but this pixel value is the okay, there is no problem for the globally, and all of those data set is the global. But when you want to use the data set for the regional, then you need to must be use the scale value. Okay, and for this scale value for the multiply we are using here this function. Okay, this 23 image we need to multiply at the same time, so that's why we are using this function in here. As well as in this time you can see we did not get the color code. This color is not appropriate. For I change it, no problem, I simply remove all of this color, and I want to show the color such as blue color. So use here the blue, suppose, then use here the suppose white, and put here the suppose green. Okay, so blue color is showing for the water body, white is that build up area or sun or rocks, and dense vegetation is showing as a green color for this region. Yeah. Okay, we can get this the proper map about this result. If you want to check the pixel value from here, now click on the inspector tab. Suppose I click on the any water body in here, suppose click on here, I can get the negative pixel value, you can see, and this pixel value is the within the range -1 to +1. So I click on here, I can get this result. Okay, so this is our NDVI map we can get, and for the dense vegetation you can get the highly positive value 0.7. Okay, 6. Yes, please.
Scale NDVI process code. I did not understand.
NDVI process, which part you did not understand?
So the
Okay, take me about the line, which line you don't understand?
16, 14 to 16.
14. So 14 to 16. Okay, so basically in this time, so first of all you have to know about the function. Function mainly we can use for reuse our code and make it easier to read. In this time, my main target is that I want to multiply with my scale factor 0.001. I just multiply all of those images. In this time, how many images I want to got? I can get total 23 images. Okay, these 23 images I want to multiply with the scale factor 0.001. Okay, I want to use the function. So I take a function variable name, look like that, and create this function. This is my function. And how I can create this function? I use the element name image, and element name basically as a variable. Okay, I use the return this image. It will be multiplied with my scale factor. Okay, in this time image, how much element in here? Element is only for the one. Only for the one means that only for the one image. But I have also rest of other 22 images. So that's why after multiply, when I multiply this image with this scale factor, it creates a new properties. Suppose you want to multiply 5 into 10. Suppose we multiply 5 into 10. you can get the 50. You can get the 50. So after multiply this 10, it create the new properties. And the same things also apply in here. You can see, suppose I multiply this image with my scale factor, so it create a new properties. Okay, when I apply these properties, all of those images which are available system time instant and system time end. System, what is the system? System means that it is my system. Okay, so this is my code. This code, overall code, is a system, and this system I already define a start date and end date, start time and end time. Okay, so that's why I apply these properties and apply it from the system time start and system time end. Okay, it means that it multiply all of those images. Okay, first of all, only for the one image I take and multiply with that, and then copy this image properties and apply from system time start and system time end. Okay, and then when I create this function I need to add with my collection. This is my image collection, and you can see map function. What you can get in here, you can see map function. Map function, mainly we can put the algorithm. Okay, in this time, what is my algorithm? My algorithm which I write in here, you can see after the map function I use here the put the algorithm. So this is my algorithm. Okay, for multiply all of those images with my scale factor. So this is my algorithm. This algorithm I want to add with my collection. So I use here the map function. So I simply call my collection 23 images and then apply this algorithm. Okay, so you can see also get the result. You can see maps and algorithm over a collection. So over a collection, when you want to connect that your algorithm, then you need to use here the map function. Okay, this is my algorithm. This algorithm I want to add with my collection. This is my collection. 23 images is my collection. Okay, so any question about that? Or any doubt? Okay, so let's go about the next part. Okay, so now I just simply, okay, and not only for that, we are also export this type of map as a TIFF format. For the exporting part, I also try to show you the later after talk about the satellite image filtering process. Okay, because both of the exporting process is the same. Okay, then we are also related with each other. Okay, and also try to discuss the NDVI time series chart. Okay, so let's go. So in this time, suppose I want to calculate this time series chart about the NDVI. How we can easily calculate the NDVI time series chart for this region, and also show the temporal change in when the NDVI is the high, when the NDVI is the low. We can easily identify how we can easily create the time series chart. So let's go about that.